In the vast theater of nature, few phenomena captivate the imagination like the exploding ant. Imagine a tiny insect, no bigger than a sesame seed, capable of destroying itself to defend its colony. This incredible ability, known scientifically as autothesis, literally means self-destructs. But it's not a random act of violence. It's a calculated strategy, an ultimate sacrifice made by a creature that understands the gravity of its situation. Under normal circumstances, these glands are sealed shut, keeping the potentially lethal contents at bay. However, when the ant faces a threat, often a rival ant or insect intruding on its colony, things change dramatically. The term autothesis is derived from the Greek words autos, meaning self, and thesis, meaning to put to death. Ants, especially those belonging to the genus Colotopsis, live in highly organized colonies with a strict division of labor. The queen's primary role is to lay eggs, while the male ants fertilize these eggs and protect the colony. The sterile worker ants perform tasks such as foraging for food, caring for the young, and defending the nest. Typically, older worker ants or those with specialized defensive roles are more prone to engaging in autothesis. The timing of the explosion is also critical. Premature detonation might miss the target entirely, while delayed reaction could allow the threat to escape or inflict damage on the colony. These remarkable insects demonstrate that under certain circumstances, individual sacrifice for group benefit can be a successful evolutionary strategy that promotes the survival of genetic lineages and social structures. This suggests a sophisticated neurological system that can rapidly assess threat levels and trigger the appropriate response. Every new video brings you closer to the wonders of nature, from the smallest insects to the largest mammals, from the depths of the ocean to the heights of the sky. Until next time, remember, in the grand theater of nature, there are always more acts to unfold and more mysteries to solve. Join us in this journey of discovery and let us explore together what makes our planet so incredibly special. Interestingly, research has suggested that certain chemical signals can override normal self-preservation instincts in ants, allowing them to commit to the explosive action even when it means certain death. This neural override mechanism represents a remarkable example of how social insects have evolved to prioritize colony survival over individual survival. Younger ants and those with important reproductive functions are generally protected from situations that might trigger explosive behavior. This strategy ensures that the colony's most valuable members are preserved, while still maintaining an effective defense system. They are testament to the adaptability and resilience of life on Earth. Their ability to modify their behavior based on environmental cues and threats is a powerful example of natural selection in action. Moreover, their willingness to sacrifice themselves for the greater good of the colony challenges our understanding of what it means to be an individual in the natural world. As we continue to explore the complexities of their behavior and the science behind their explosions, we not only deepen our understanding of the natural world, but also gain new perspectives on the concepts of selflessness, strategy, and survival. This division of labor is crucial to the colony's survival. If one or more of these roles are not fulfilled, the colony may collapse. Therefore, the survival of individual ants is secondary to the success of the colony. This prioritization of the colony over the individual has led to the evolution of explosive defense. By sacrificing themselves, the worker ants are ensuring the continuation of the colony and thus preserving their own genetic material. It emphasizes that the exploding ant willingly sacrifices itself to protect its colony. In the case of exploding ants, a worker ant shares a significant portion of its genes with its nest mates, especially its sisters. They assess the situation before deciding whether to commit to this extreme measure. If the threat is minor, they resort to normal defensive tactics such as biting or stinging. But when faced with a major threat that endangers the colony, they spring into action. They release chemical signals, engage in mock battles, or even sacrifice themselves to protect their colony mates. By protecting the colony, the worker ant is safeguarding its sisters, who are also its relatives. This means that even though the individual ant is dying, its genes are being passed on to the next generation through its surviving sisters. This remarkable adaptation highlights the power of evolution and the lengths to which nature will go to ensure the survival of a species. This altruistic behavior is one of the most compelling aspects of the exploding ant. The ant's decision to explode isn't based on external cues or learning. It's an instinctive response, a drive ingrained in its genetic makeup. But this raises a crucial question. How did such behavior evolve? How did natural selection favor an action that seemingly goes against the basic principles of survival? The ant perceives the danger and sends out chemical signals that alert its nest mates. Simultaneously, it begins to contract its abdominal muscles with incredible force. This contraction increases the internal pressure until the delicate balance of the ant's body is broken and the sticky substance is released. In a matter of seconds, the ant goes from being an ordinary insect to a tiny biological bomb, detonating to protect its colony. This behavior raises profound questions about consciousness, strategy, and survival in the animal kingdom. The toxic substance released by the exploding ant is a complex mixture of defensive compounds, including alkaloids, phenols, and other toxic organic molecules. It's not merely lethal, but also serves to trap and disable the enemy. The sticky consistency of the substance ensures that the attacking ants become entangled, gluing their legs and antennae together. This immobilizes them, making them easy targets for the rest of the colony to dispatch. Furthermore, the pungent smell of the explosion acts as an alarm, summoning other ants to the side of the attack. This creates a united front, a formidable defense that overwhelms any intruder. Do they strategize, or do they blindly follow instinct? Are these insects aware of their impending demise? And why is such a drastic measure sometimes the only solution to their problems? This is more than just a natural oddity. It's a window into the minds of some of the most intricate creatures on our planet. Join us as we unpack the mystery behind exploding ants, exploring their behavior, biology, and the evolutionary pressures that have shaped them into the warriors of the insect world. But before we delve into the heart of this fascinating topic, let us take a moment to acknowledge the elephant in the room, or should I say the ant in the anthill. This channel thrives on your support. So if you find our exploration of the natural world intriguing, several species across the globe exhibit this bizarre behavior, but the star of the show is undoubtedly Calotopsis explodens. Found in the rainforests of Southeast Asia, these ants have earned their fame through remarkable displays of explosive power. To understand the mechanics of their destruction, we need to first examine their anatomy. At first glance, an exploding ant looks like any other ordinary ant, but beneath its tough outer shell lies a unique adaptation. Specialized glands are located throughout their abdomen, and these are the key to their explosive defense. When activated, these glands release a sticky, toxic yellow substance that builds up pressure within the ant's abdomen. It's an instinctive yet highly effective form of chemical warfare. What follows is a violent rupture of the abdomen's cuticle, the outer protective covering, sending the toxic goo flying in all directions. This is not a mere accident. If you'd like to be a part of our journey, consider becoming a member. Your support enables us to continue producing top-quality videos that bring the wonders of nature right to your fingertips. Now let's turn our attention back to the amazing exploding ants and the mysteries that surround them. Exploding ants are not a myth or a figment of a tropical nightmare. They are real, and they are many. But what triggers this explosion? However, the story doesn't end with the explosion. But why is this behavior called autophasis? Why not simply call it explosive defense or suicide attack? The answer lies in the unique social structure of ant colonies. This concept is known as kin selection, a form of natural selection that favors traits that benefit not just the individual, but also its relatives. But the story does not end here. There are many fascinating aspects of exploding ants that remain to be explored. For instance, these ants don't explode randomly. Furthermore, not all ants in the colony are equally likely to explode. The explosion itself is a carefully orchestrated event. The ant must position itself strategically to ensure that the explosive discharge hits the target effectively. The study of exploding ants has provided valuable insights into the evolution of altruistic behavior and has implications for understanding cooperation and sacrifice in other social species, including humans. In conclusion, exploding ants are not just bizarre anomalies in the insect world. And if you're as fascinated by the natural world as we are, we invite you to subscribe to our channel. Thank you for joining us today.